Hello guys, welcome back with ComfyUI 2025. Today, we're diving into the brand new Wan 2.2 Speech-to-Video S2V in ComfyUI. This model is a powerhouse that generates video by combining an image with a speech file. Think of it like infinite talk but with a trade-off. While the lip sync might not be quite as sharp yet, the overall video quality and realism are on a whole different level. It really depends on what your priority is: perfect lips or a stunning cinematic result. Let's get into it. Before we start, we need to prep our environment. Wan 2.2 S2V support is new. If you don't update, it simply won't work. Check the video description for a link on how to update and fix common errors after update. We'll be using GGUF models, so you need the ComfyUI GGUF node. Even if you already have it, a ComfyUI update can sometimes break custom nodes, so go ahead and update that node specifically to save yourself a headache later. Now let's go shopping for our models. You'll find all the links in the description. For Wan 2.2 S2V model, I'm using the version from QuantStack. Since I'm running an RTX 4060 with 16GB VRAM, I chose the Q4K model. Place this in ComfyUI /models/diffusion models. The V, good news, it uses the same VAE as Wan 2.1. Drop that into ComfyUI /models/V. Lightning LoRA. To speed things up, we'll use the LiDX2V LoRA. This allows us to get great results with fewer steps. Put this in ComfyUI /models/LoRa's. Text encoder, we're using the UMT5 XXL FP8. This goes into ComfyUI /models/text encoders. Lastly, download the WAV2 large English model and place it in ComfyUI /models/audio encoders. With our files in place, let's build the workflow. First, we need to load everything we just downloaded. Add UNet Loader GGUF and select the Wan 2.2 S2V GGUF model. Add load CLIP and select the UMT5 XXL FP8 model, also change its type into WAN. Add VAE loader and select your Wan 2.1 VAE. Add audio encoder loader and select the WAV2 model we just grabbed. Add LoRA loader model only and select the LiDX2V LoRA. Make sure to connect your UNet loader output directly into this LoRA loader node to ensure the acceleration is applied correctly. Now that we've loaded our models, let's bring in our media. For the audio, you could use the standard ComfyUI Load Audio node, but I highly recommend using Load Audio Path from the Video Helper Suite VHS.
And my mom thinks she's a little bit loud, but she's the only one who stands out in the crowd. Yeah, she's the only one who's figured me out.
To make Wan understand our sound, we need to translate it. Add an audio encode node. Connect your load audio output and your audio encoder loader to this node. Next, we need the face we're going to animate. Again, I'm using the load image path node from VHS. Wan 2.2 S2V is picky, it only accepts dimensions divisible by 16. To avoid manual math and errors, add the Wan video image resize to closest node. Connect your image to this, it will automatically snap your width and height to the nearest resolution that the S2V model can actually process. I set my width and height to 640 and set aspect ratio preservation to crop to new. Finally, we need to tell the model what we're looking at and what they're gonna do. Add 2 clip text encode nodes for your positive and negative prompts. Connect the clip output from our loader to both of these. Since we are using the Lightning LoRA we loaded earlier, we are going to set our CFG to 1.0 later in the sampler. Because the CFG is at 1.0, the model won't actually look at the negative prompt, it's essentially ignored. So save your time, you don't need to write anything in the negative box for this specific Lightning workflow. Now add the Wan sound image to video node. Think of this as the brain where everything meets. Plug in your positive and negative prompts, your VAE, and that encoded audio we just made. Don't forget to link the resized image and the width/height dimensions. This node will output a latent, which we will then plug into our sampler to finally start generating. Set the length based on your audio. However, keep in mind this model needs at least 73 frames to function properly. If you push this number too high, you'll hit an out-of-memory error pretty quickly. I will talk about extending on future video. For now, let's leave it at the default. As for batch size, keep it at 1. If you don't like the first result, it's much safer to just change the seed and run it again than to crash your GPU trying to do 2 at once. Next, we need to add the model sampling SD3 node. Connect your LoRA output to this node. What does this do? Since Wan 2.2 uses a flow matching architecture, similar to Stable Diffusion 3, we need to set the shift value. Set this to 8.0. By increasing the shift to 8, we are telling the model to focus more on the refined parts of the noise during the sampling process. This is crucial for video models like Wan to ensure the motion stays smooth and the image doesn't fall apart into static. Finally, it's time to bring in the K-sampler to start the heavy lifting. Connect your model from the sampling node, your positive/negative conditioning, and the latent from the Wan sound image to video node. Since we are using the lightning LoRA, you can set this to minimal 4 steps. Set CFG to 1.0. Remember, the lightning LoRA is designed to work without CFG guidance. For sampler use UniPC with simple scheduler for the cleanest results. K-sampler will make a latent representation of our video. To actually see it, we need to bring it back into the visual world. Add a VAE decode node. Connect the latent output from your K-sampler and the VAE from our initial loader. This is the translator that turns those math coordinates back into actual pixels. To turn those frames into a playable file, add a video combine node from the video helper suite. In the video combine settings, set the FPS frames per second to 16. This is a great sweet spot for Wan 2.2 S2V. It keeps the motion smooth without making the lip sync look sped up or unnatural. Set the other setting according to your taste. Everything is wired up. Our models are loaded, our audio is encoded, and our image is resized. Let's hit Q prompt and generate our first video.
She's a little bit loud, but she's the only one. And my mom thinks she's a little bit loud, but she's the only one. And my mom thinks she's a little bit loud, but she's the only one. And my mom thinks she's a little bit loud.
Look at that smooth motion and realistic quality. While the lip sync is still evolving, the cinematic look of Wan 2.2 is hard to beat. The result looks great, but if you look closely at the very first second, you might notice the first frame looks oversaturated, almost like the VAE is burning the image. Don't worry, there is a clever workaround for this. We're basically going to create a sacrifice frame, add a latent cut node and connect it to your K-sampler output. Set the dim to T, which stands for time. By setting the index to 0 and amount to 1, we are specifically grabbing just that very first frame of the latent. Next, add a latent concat node. We're going to plug that single frame we just cut back into the main latent sequence. Set the dim to T. This essentially duplicates the first frame, giving us 2 identical frames at the very start of the video. Now when we run the VAE decode, the burn effect will usually hit that new first frame. To fix our final video, we use an image from batch node. Set it to start at index 1 and max its length, but if you want to be more precise, you could use batch count and math expression. Just use batch count minus frame count to use as the batch index. By doing this, we skip the glitched sacrifice frame and start our video from the clean second frame. Use this output for your video combine, and you'll have a perfectly smooth start with no color burning.
I think she's a little loud, but she's the only one. And my mom thinks she's a little bit loud, but she's the only.
Here a comparison side by side. As you can see, the quality is fantastic now. By using that sacrifice frame trick, we've eliminated the VAE burn and achieved a smooth, high-quality start to our video. To give you an idea of what to expect, generating a 640x640 video with 77 frames takes roughly 400 to 600 seconds on an RTX 4060 Ti, with 16 GB of RAM. It's not the fastest process, but for this level of quality, it is absolutely worth the wait. Now, I know many of you want to make longer videos, but increasing the frame count too much will lead to out-of-memory errors. In my next video, I'm going to show you a specific technique to extend your video duration without crashing your GPU, so make sure to stay tuned for that. Thanks for watching. I'm KRCOW 2025, and I'll see you in the next one.